Hello, good morning. We are going to start in a couple of minutes. Hello, hello. Good morning. My name is Philippe. I am the CEO of ReadWrite Labs, and welcome to our weekly webinar. Today, we're going to talk about big data. This is a long overdue subject. We've been asked to talk about it for a long time now, as this is one of the key piece of infrastructure that people need to build if they want to build one of those new implementations especially for IoT purposes. So moving to the next slide, Kailash, just to give a little bit of background for us, for the people who don't know us. We are ReadWrite Lab. We are the research analyst firm for the Internet of Things. We provide research through our platform, readwritelabs.com. We also have a network of experts and partners that we're working with. We provide visibility through our newsletters and landscapes. So we identify companies and we work with those companies and promote them through our newsletters. And we also provide education as well. Next slide. So if you look at our platform, we have an AI-powered platform combined with curation that enables us to track about more than 100,000 keywords now across the entire landscape of digital transformation. So we cover spaces like smart humans, digital transformation of the enterprise, mobility, what we call customer X, and infrastructure. Within infrastructure specifically, we cover blockchain, AI, and all the connectivities, LoRaWAN, narrowband IoT, and Sigfox. We crawl the web, we get all that information, we identify that information, we catalog that information, and then with our leading experts and our community, we work to figure out what makes sense and what are the insights that we should put forward. You can access all that research at readwritelabs.com. Moving forward. So today we're going to talk about big data. Just to set the ground, you have two ways to ask questions. One way is through the Q&A. You can ask questions through Q&A, or you can ask a question as well through chat. We are going to monitor those questions, and either those questions are within the flow of the presentation, and then we'll ask, and the analyst and myself will review those questions then, or they are not on the flow. And if they are not on the flow, we'll ask them during the Q&A session, which is going to start around 9:45 or 9:45 a.m. PST. So in about 45 minutes. So very quickly, right, to give a sense of where we are and why it makes sense, right? In 2019, Cisco predicts that about 500 zettabytes of data will be collected this year through IoT devices. For people who don't know what zettabyte means, a zettabyte is 1 trillion gigabyte. So about 500 trillion gigabytes are going to be collected this year through IoT devices. And the growth of data gathering is not going to grow linearly, it's going to grow exponentially. So all the systems that currently exist will be flowed with data and won't be able to sustain the load. And so we need a new way to think about. You need a new way to think about storing data. We need a new way to think about interacting with that data. And so we are today releasing this big data landscape. It's a V1.0, so we don't pretend it's perfect, and there are probably some issues associated with it. So please provide as many feedback as you can to Kailash and myself. We are also not going to talk about some of the major issues facing those type of implementations, such as data ownership, privacy, credibility of that data. Is this data accurate? So the validity of the data. We're not going to talk about all those issues that are going to be major issues moving forward when it comes to implementation of those technologies. And so the goal of this webinar is truly to familiarize yourself to how we are looking at the space, and then to get feedback. Today I'm joined with by Kailash Suresh. Kailash, do you want to say a few words?
Yeah, really excited. Thanks, Philippe. Good morning, everybody. The big data space is a big space, and it's been really interesting doing a lot of research in this space. As Philippe mentioned, this is the V1.0, and we're always looking to learn. So if you have any comments, please feel free to reach out to us.
All right. So very quickly, what we thought we would do is to give you a sense of where we were 10 years ago, right? And so if you look at where we were 10 years ago, we started on the lowest side, right? So you had those integration platform, right? That the data system, the system were accessing other applications. So you had the data integration layer and the data transformation layer. You had about 4 different set of databases. So relational database, of course, right, were the main layer. Then you have the massively parallel processing database, such as Vertica and the like for massive data warehouse. Then you had Hadoop, and then you had the security and the management and monitoring layer. And on top of the databases, you had analytics platforms. So you had the BI platform and the visualization. You have statistical computing, so software like R and SAS. And then you had search and speech, and then log analytics. And then on top of those analytics platform, you had some vertical applications that were leveraging the power of what you have available. And those applications were available everywhere, right? So sales and marketing, social analytics, agriculture, you name it, there is analytical application for any type of data sets. And so if you move forward one layer, what happened between 2010 and 2019 is a new set of data appeared. Video appeared, and then between 2000 and 2019, the amount of data that has been gathered that were either in a structured form or a document or a voice has increased 100x, right? So more data and then new data sets is what happened during the last 10 years. Then some things that happen even that happen even more now is the need for real time, right? So with all the device being connected now, everywhere, from starting with the phone, right? But the cars and the smart homes, the voice, the Alexa, all those Alexa implementation created a need for real-time data access and processing. And so that need for real-time. Then the third piece is new analytics platform. So in order to, because there was a massive influx of data, because there was a new data sets, and because the way we access the data, the way we need to treat the data is different, we needed the new analytics platform and new type of databases. And so in terms of new analytics platform, that's when the NLP platform emerged, machine learning and deep learning. And then in terms of new databases, that's when the new SQL database, so Cassandra, MongoDB, graph database like Neo4j, and the time series database, and the streaming analytics database emerges as well for anything that is a real-time need. So if you look at the new landscape, you see few things emerging on the database side. You see the emergence of time series data. I mean, NoSQL and graph database, right? To take into consideration the new type of document and the scale of the data. And then for everything that is event management, so time series database and streaming analytics. And then on top of that, you see the emergence of natural language processing, machine learning, horizontal AI, natural language processing, machine learning, and horizontal AI as new analytics platform. So now what we'd like to do is to go over each segment one by one, and Kailash is going to do that for us.
All right, and before that, this is the overall landscape that we are launching today, and we will be sending this across over email, and so you should have that soon. So let's start off by looking at the landscape by segments and see what is really happening, right? So let's start off with the cluster components. A cluster component is basically a group of independent computers that are working together. And this is mainly done to enhance the availability of your servers. Mesosphere is an example of a company in this space. Their DCOS is a cloud scale operating system that operates all the servers in your infrastructure as if it were one giant computer. So then we have the Spark, right? So Spark is an engine for big data processing. Apache Spark is open source. It's 100% open source and was developed by a team at Berkeley. The same team went on and founded a company called Databricks, which recently raised $250 million in their Series E. So the main advantages of Spark are that it's much faster for processing large-scale data. It has easy to use APIs, and it comes with higher level libraries. So support for SQL queries, streaming data, machine learning, and graph processing is built in. And the third part here is the storage, right? So storage is basically the shared storage which runs across virtual IOs. And Pure Storage is one of the examples of a company in this space. They have an all-flash storage, and you can use that to run mission critical databases and enterprise applications. Then we move into the security aspect. Right? Now, security is one of the key challenges when it comes to big data management. And if you think about the mission here, it's fairly straightforward. It's basically not allowing unauthorized users access to confidential information, right? And there are multiple ways to do this through firewalls or strong user authentication, end user training, and then you have the intrusion protection and detection systems. And then if these systems are compromised, you have encryption of your data, both at rest and in motion, to make sure that you're adding a second layer of protection. Now, one of the main challenges here is the data flow is not linear and has multiple points where it can be compromised. So when you think of data security, you need to think of it in three different stages. One is securing the data sources. The second one is looking at the stored data and building security around that. And finally, the data that you're outputting to your dashboards or even to your partners need to be secure. Looking at the data sources, you mainly have the user-generated data, which includes any entry to a CRM, transactional database data, um, the vast amount of unstructured data such as emails and social media posts. And this existed over a long period of time. What's new today is the emergence of the whole world of machine-generated data. And these includes logs, sensors, data from cameras, etc. And you need to here focus on securing the data in transit from the source to the platform. Now, when it comes to the stored data, protecting stored data takes basically encryption, and you also need to focus on strong user authentication. What's challenging today is you'll need to run your security toolkits across a distributed cluster, which has multiple servers and nodes, and also systems which are both on-prem as well as in the cloud. And another key component which has emerged and that should not be forgotten is to protect the log files as well as the analytic tools that are generated within the platform itself. The third stage is looking at the output data. And here the analytics generated from big data output results to the application reports and dashboard, right? So these are the primary reason of having your big data infrastructure, and the reason that these intelligence that you are deriving from the big data is super valuable, that attracts a lot more attacks. And so securing and protecting these both at your end as well as your partners' end through APIs are also required. Illumio is one of the companies that's expected to IPO later this year. They raised 65 million in February, and they're a company to look out for. Source is another example of a company in this space. Then let's move on to monitoring, right? So if you look at monitoring and management, it is a different challenge today as it was 10 years ago. As mentioned, back 10 years ago, there was one programming language, more or less, and an application basically ran on one operating system, which was present on one physical server. Today, the diversity of the modern application stacks and the rate of change of both the application and the infrastructure layers requires monitoring to become more granular and frequent. There is also a need to do this across the multiple vendors that you currently have in your IT ecosystem, and so it turns into a multi-vendor big data problem. AppDynamics, SolarWinds, Zoho, Datadogs are examples of companies that provide management and monitoring services. So moving one layer up, we have the integration platforms. According to Gartner, there has been a 60% growth in the API integration from 2017 to 2018. And by 2021, it's estimated that the integration platform market will increase to $4 billion in revenue. So data integration involves combining data from different sources while providing a unified view of the combined data. This enables you to basically query all of your data from a single interface and derive analytics and insights. So these platforms basically help companies manage data silos. If your data is spread across multiple teams and databases, it can take a long time to gather, process the data until you can finally analyze it. And given the amount of real-time analytics that's required, you need to make sure that there is a integration system in place which gives you access to this prior to you needing to do it, right? And here Illuma is an example of a company which was recently acquired by Google. One of the things that most of these companies are good at is also helping with migrating to the cloud and cleaning up the data. Then we move on to the database. The database is probably the most critical component of this architecture, and we have seen a lot of activity in this space. So let's start off with Hadoop, right? Hadoop is not a type of database. It's a software ecosystem that allows for massive parallel computing. It is an enabler of certain types of NoSQL distributed databases, which can allow for data to be spread across thousands of servers with little reduction in performance. And this framework has been adopted by multiple companies. Amazon, Elastic, MapReduce, MapR Technologies are some examples. Then move to the NoSQL, or commonly referred to as not SQL. And this represents a different framework of database that allows for high performance, agile processing of information at a massive scale. So it's a database infrastructure that has been very well adapted for today's heavy need for high demand, big demand of big data. So the efficiency of NoSQL can be achieved mainly because, unlike the relational databases that are highly structured, NoSQL databases are unstructured, and there is a trade-off between stringent consistency as well as speed and agility. So while data volumes are always growing, what's increasing at an even more exponential rate is the connection between your data points. And that's where graph database becomes highly valuable. SAP HANA, MapLogic are some examples here. And one of the key advantages here is, as you scale and as your data connections grow, the performance of graph database more or less remains constant. So another company in this space, ArangoDB, raised 10 million in their Series A funding last month, and they are being used by some of the top organizations worldwide, including Airbus, Barclays, etc. We then have the NewSQL databases, and NewSQL is a class of modern relational database management systems that seeks to provide the same scalability of performance as the NoSQL systems. And these are mainly used for online transaction processing. And so things like bank transactions, which need a guaranteed guaranteed record as a traditional database system, but also need speed. So we then move to the next set, which is massively parallel processing databases, and these is coordinated processing of a program by multiple processors working on different parts of the program. So each processor has its own operating system and memory, and what this does is basically speeds up the performance of huge databases. As mentioned earlier, Vertica is an example of a company, and they use MPP to power their analytics engine. We then have the relational databases, which are more or less which have more or less been there for a long time. These includes your MySQL and PostgreSQL, etc. Finally, we have the time series database. Now, a time series database is a software system that's optimized for handling time series data. Right. So if you think of most of the news sources of data, be it sensor data from IoT or data that's transmitted within in the connected car or autonomous vehicle ecosystem, they all need to have a time series database in place. Influx Data, one of our partners, is a very interesting company, and they have developed multiple use cases. One of these use cases that they have developed in partnership with VMware is to manage time series data coming out of IoT devices, and that's That's a good company to look out for. So then moving on, we have event management. So as mentioned earlier, event management is a new segment, or streaming analytics is a new segment that has emerged since 2010. And stream processing analyzes and performs actions on real-time data through the use of continuous queries. So it connects to external data sources, enabling applications to integrate certain data into its application flow, or also have the ability to update an external database. So this has the ability to also calculate statistical analytics while moving within the stream of data. One of the leading companies in this space is Stream. We had the opportunity to speak with them at the recent Strata conference. And what was really interesting is the amount of use cases and the scale at which they are building solutions. They have pre-built pipelines and out-of-the-box wizards for configuration and coding. They have a very simple drag and drop dashboard builder, and this really speeds up the time to deployment. There are several use cases from transportation, financial services, healthcare, e-commerce as a result of Stream's technology. You can, and they have a list of different use cases that you can read further on their website. The message bus is a way to exchange messages between point A to point B or multiple points. And messaging enables distributed communication that is loosely coupled. So you don't need the sender and the receiver to be present at the same time. They can receive the same message in an asynchronous manner. RabbitMQ is one of the leading companies in this space. Now, on top of the databases and the infrastructure, we then have the analytics platform. So it's an abstraction layer which enables users to query the underlying data. Right. So if you look at the different segments, they include the intelligent platforms, the visualization, and statistical computing. Then you have the log analytics, speech and search, and NLP. And you have the ML related and AI related.
Hey, Kailash, sorry to interrupt. We have a question which is, what is the best database type that fits the data mining techniques for analyzing a big data set? So very broad question. Can you answer that question?
Yeah, I mean, it is very broad. So if you ask any company, they would obviously say that their database is the best for managing big data. But we need to break this down into what are you really looking for, right? So what are you looking for from the database? What is the source or stream of data that needs to be analyzed? And based on this, you kind of select different databases. So it's very common to have multiple databases within your IT infrastructure for different use cases. And if you are an IoT company, for example, creating an autonomous vehicle, then you obviously need your time series based databases. Let me go back. So you still need your time series based databases for analyzing sensor information from either cameras, lidars, or other sensors. At the same time, you would also need your traditional database for record keeping and diagnostics. So does that answer your question?
Yeah, I think that answers the question very well. Thanks, Kailash. So at the end of the day, it's a question of what is the use case, right? And depending on the use case, certain databases are better suited than others. And so really think about the use case first, and then think about the database you're going to be using.
Awesome. So then we have the analytics platform, right? So if let's talk about the BI platforms, which are fairly popular. They provide three basic capabilities. So one is the analysis part, the second one is the information delivery, and the third one is the platform integration. So think of Tableau, Click, Domo, they're excellent examples of these. The information delivery basically are reports and dashboards. The platform integration is the ability to integrate multiple data sources. And then visualization platforms are very closely related to BI platforms, but these focus on visually displaying insights from the big data. They include similar companies, but some companies to look out for here are Google Data Labs and Power BI as well. Statistical computing has been around for a long time, and they include tools like SPSS, R, Python, MATLAB, and so they still are required and continue to exist. So then we look at the next set, which is log analytics. Now, one of the most important pieces of information that you're generating is actually from your systems, and these are the logs. And there are companies focused on helping you derive insights from all the log data. Splunk is obviously one of the famous companies in the space that enables you to derive insights from your logs. And if you think about an organization, they can use log analytics to uncover patterns in user behavior. They can identify problems. They can audit security activities or ensure that compliance with established rules are in place. They can also, this also is a key component for their planning phase. And so they also use this to plan future IT infrastructure or any changes that are required. We then go to the speech platforms, right? So speech platforms can are basically, either speech to text or text to speech. Here it's the speech platforms basically help to decode an audio file and then provide the probability of what is being said. So if you have my audio recording, the speech platform basically gives you a certainty or probability of the word that I'm speaking, right? And so here two examples, Voicera and SoundHound. Voicera has an interesting application. They have a meeting assistant that captures notes based on the audio of a meeting. So if I have their voice bot in this webinar, it would basically transcribe all the audio that was heard. They also are trying to build analytics on top of it by trying to provide action item extraction. And so that's really moving into the NLP space, right? So before, and so what's really happening in the speech space is the massive amount of growth that's seen in the smart home space in terms of smart speaker adoption. And with smart speakers now running Alexa or Google Assistant, there is a huge amount of data that needs processing, and so speech platforms are thriving at this point. We then have the search platforms. These help businesses across industries quickly create relevant and fast search, and this is really looking at improving the customer experience. Algolia Search, AlphaSense are a couple of examples. AlphaSense basically focuses mainly on business data, and so they've built a niche for themselves there. NLP, as I mentioned earlier, it's how to. So the challenge here is how do you how to program and analyze large amount of natural language data that's being received today, and understand the context and really do that from a computing perspective, as opposed to a normal human conversation. The last two segments, the machine learning related one and the horizontal AI, have a lot of companies, and we plan to build separate landscapes for these. And so we would basically be focusing on this on a separate landscape. But some of the platforms that I can mention here is one of the most popular one is H2O. H2O is the #1 open source machine learning platform for enterprise. They have built several use cases from claims management, fraud detection, to advanced analytics. And in terms of horizontal AI, they are basically general purpose AI, and you see mainly bigger companies with deeper pockets investing in this space. If you're a startup, you're much better off focusing on vertical applications that are more specialized. And then, so the applications, in the interest of time, while we can go through each of them, I think the main applications that are built on top of these range from sales to sales and marketing, social analytics. There are a lot of agricultural use cases. You have legal and government-based use cases. Then you have supply chain, retail. So there are multiple applications that are being built on top of this infrastructure. In terms of sales and marketing, companies are using big data to really understand the market conditions better, and to determine the optimal price for a product. So that's one of the applications that you can see in the sales and marketing space. The other one is determining the optimal price cuts to ensure that there is a stock clearance, right? And of course, when you look at marketing, it's mainly to do with marketing budgets and how do you manage and automate setting up marketing budgets and marketing campaigns. Adaptly is one of the examples of a company here, and they were acquired by Accenture Digital recently. You can then also have personalization and customer experience. So Lytix is an example of a company there. Social analytics is growing at a very quick pace today, given the amount of social interaction and how it's become a key component of a company's strategy or branding strategy. And Bitly, Hootsuite are examples here. If you look at agriculture, you have accurate crop prediction, real-time insights. These are the main use cases here. AgroStar is an agtech company in India that provides farm automation and management services. FarmLogs is another company which helps you monitor field conditions, plan and manage crop production, as well as market your grains, right? Then you have human capital and big data. It's mainly used around build like companies like Glint. They have a people success platform, and these platforms are built on a big data approach or data analytical approach. Mocha is a SaaS software company that helps companies optimize recruiting services. They recently raised 27 million last month. In the legal side, you have multiple companies. Socrata is an example that works with governments, and so that's the legal and government use cases. CRM, InsideSales.com is a perfect example here. They help companies build customer pipelines. When you talk about security, we've gone over this but ProtectWise is an example of a company that was acquired by Verizon last month. They capture full fidelity network traffic from enterprise, cloud, and hybrid environments, and create a lasting network memory. Supply chain is one of the hot areas for big data application, purely given the amount of data that's coming out of these systems. And so things like out of stock detection and prevention are key here. And and so let's, I think retail applications are more or less straightforward. They have, there is a wealth of information that's readily available, and companies are understanding their customers much better and in order to market to them and convert them. And more importantly today, retain them, as most business models move towards a subscription one. So we have real estate applications, a couple of uh, smart building companies like SmartSip and GeoFi. Um, and then you have the advertising and commerce and healthcare use cases as well. So that's a lot of applications. We haven't really had a chance to go in depth into each of them, but mainly due to the amount of time that we have. Let's now, turn the floor back over to Philippe and look at an interesting framework.
Yeah, and Kailash, thank you so much for having gone over the landscape. I think it's very useful because that way that give a sense to people around how things are working with each other. And of course, in terms of analytics, there is a lot going on. One of the trend I wanted to highlight for today, it's a major trend that you're going to see moving forward, is what we call digital ecosystem platform. So to give you an example of what a digital ecosystem platform is, I am today in Ljubljana, Slovenia, and I'm talking about smart city and the future of mobility around smart cities. And so, the cities right now are trying, because it's a question of cost as well, to build platforms that aggregate all data about what's happening in the city. So data coming from garbage collection, data coming from cars running on the system, data coming from a lot of variety of places. And so that data needs to be collected, needs to be categorized, and needs to be accessed by a lot of people to derive data and to derive innovation. And so if you're thinking about the requirements for those big platforms that are being built right now, and there are platforms like that for industries, like Schneider Electric is doing this for the industrial internet. Airbus is doing the same thing, so building those digital ecosystem platform for the aerospace industry. So the plane, all the data that is ongoing on the plane in real time is going to be being downloaded on those massive platforms. And every time that there is something happening within a plane, the data is being sent to the right supplier who can access the data and start looking at what the problems are. So you can see now that data is being used in real time and to drive insight and provide insight back to either the device or the business or the consumer that is leveraging that device. And so what are the requirements for something like this, right? Whether it's a city, whether it's a company like Schneider Electric or Airbus, right? You need to access data from tens of operational databases. The data needs to be open, so it needs to be accessible by everybody. You need to be able to access those data through an API, and you need to have constant access to the operational system in order to either get the data or provide insight to the system while the system is ongoing. And so we're going to show you a draft of what a digital ecosystem platform looks like. It's coming from a company called Fireware. Fireware is an endeavor between the European Union and big companies like Telefonica, Orange, a lot of the biggest companies in Europe. It's a project that has been funded, so it's a public-private partnership that has been funded in excess of 200 million euros, and they've started to develop that framework that is right now in use. I think in about 15 implementation already already, mostly cities, and there are about 120 that are in the process of being implemented. And as you can see, right, on the lower side, you have all those operational systems that are basically gathering information, right? So IoT networks, other information sources like CRM, social network, vertical solutions like smart parking, air quality, public transport, waste management, right? So all that data is being tagged by this context broker level, and the context broker basically assign some information about the data itself, whether in terms of location, in terms if it's a parking space, in terms of where is the location of that parking space, and then if it's available for buses, location, route, and timing. And for each specific species of data, there is some tagging associated with that. And then once you want to run an insights, once you want to run some analytics in order to understand what's going on, the system is going to call on the data from the different data store, operational data store, and then brings that data back to the context broker. The context broker is going to bring that data to the processing engine, and then you'll be able to run your machine learning, your Hadoop. You're gonna be able to derive the insight you want, and then those insights are gonna be then sent back to the operational systems. And so all that data is going to be accessible either by the city itself or by the companies themselves if they want, through an open data portal or a data marketplace. So fairly sophisticated systems where a lot of data is going to be aggregated to a lot of different data sources from a specific use, and is going to be accessed by a lot of individuals. In the case of Schneider Electric, there is about 20,000 data engineers that are accessing that data. In the case of Fireware, it's about the same. So think about those big systems are the systems that, if you're part of a city, or if you're part of one of those big companies, it's a system that you're going to have to live with over the course of the next 20 years in order to provide insights and new innovation to your customers and your partners. Next. And so that concludes our webinar. Do you have any questions on your side? So I have one question for you, Kailash, on my side, which is, if you look at the landscape, what are the areas that are the most invested in terms of venture investments?
Yeah, so let's just go back to the landscape. And so if you look at venture investments, right, so you see most of the vertical applications that are being developed are being done by there is a lot of startup activity in that space for vertical applications. Most of the investments are going into really building out the analytics platform, everything from stream analytics, everything that is basically needed for the future data economy, right? So things like streaming analytics, you have the time series database, influx data raised, I think close to $60 million there. So the investment activities is basically centered around those segments which are essential and which are heavily changing from the big data perspective. So security is another space which is hot.
Yeah, and then machine learning, right?
And of course, yeah, of course, machine learning, horizontal AI, and so that's another really hot space.
Yeah, no, exactly. And so we are going to build a landscape for anything associated with all those new machine learning and deep learning frameworks that are being built, as well as all the vertical applications that are built on top of it. So yes, so that's a very exciting and important space. In terms of research, we have a comment from Bruce, right? So Bruce would like us to map out the use case to the analytics platform and the data sets needed to fulfill the use case. So I think it's a great idea, and it's exactly where we're going. Right? So we'll provide that information to people as we are building it. So at this point, Kailash, we don't have any more questions, so we'll conclude the webinar. Yep.
Yeah, no, I just see one open question. Yes, James, the presentation recording will be available on the platform, and so you can access that on readwritelabs.com. You'll get an email about this. And Philippe, one last thing before we conclude, if there are no more questions, is the upcoming webinar. So next week we're going to have the Connected Cars webinar. That's gonna be presented. So we would have correction. It would be Savisha, who's the research analyst, who would be joining us as well on this webinar. That happens next week, same time, 9 a.m.
All right, talk to you soon, and maybe next week, if you're interested in connected car, I'll have plenty of information around what's happening here in Europe, both from Barcelona, Berlin, and Ljubljana. Talk soon. Bye.
Thanks. Bye.